Okay, so now flipping the argument the other way, we just talked about why repeated measures designs, or things that repeated measures designs, advantages they have over independent. So what are some advantages of the independent measure design of using two separate samples? Your book talks about a couple that we're going to go through, but they all relate to really the same idea in a sense. Independent measures design studies tend to be a little faster. Think about what I've said before. If we wanted to study the differences in some tasks between 3 and 4-year-olds, we said the repeated measures design is the preferred way to do that. Get a group of 3-year-olds, measure them, send them home, bring them back when they're 4. Well, notice that means you have to wait an entire year to get your data. Well, with a repeated measures design, you wouldn't have to wait that long. Get a group of 3-year-olds today, you can go get 4-year-olds tomorrow if you're that fast. So you can get done in typically weeks what may take months the other way around. Now that's not listed as a specific advantage in the book, but we'll see that connects to two of the advantages that they do talk about. So the first is that we can reduce the chances of a problem called the history effect. The history effect is when real-world events unrelated to your study happen that have an impact on your sample, on your subjects. So while you're running your experiments over the course of, again, typically weeks or sometimes months, these things are being run, the opportunity for real-world events to occur that might affect your subjects can come into play. So the pretty classic example I use is if I wanted to study the development of the natural, typical social and emotional development of kids between the ages of, say, 3 and 4, well, if I did that as a repeated measure study, we just said I'd have to get them when they're 3, measure them, wait a year, and bring them back when they're 4. Well, during that year, anything could happen. There could be a major terrorist attack in their town, which would certainly have an impact on their social and emotional development that would be atypical, that would be abnormal, which isn't what I'm looking for. A historical event has happened. It doesn't have to be that type of historical event, but that's the kind of thing that could happen. Or think about what went on, well, still was really going on with the drinking water in Flint, the lead contamination. If I'm trying to see how the cognitive abilities of children develop between the ages of 5 and 6 and they're drinking lead, that's a history effect. That's a problem that we're going to have in my study, because the lead is going to have an impact on their intelligence more than the treatment, more than the time itself will. But if I do this as an independent measures design, I go get 3-year-olds today and 4-year-olds tomorrow, there could still maybe be a history effect that happens, but the opportunity is much smaller because we're finishing the study faster. So we're closing the door on the study as fast as we can, which just gives the universe a shorter window to come and throw sand in the machine, if you will, to come and mess it up. So it can't eliminate it, but it can make it less likely by speeding things along. The second one we'll have here, and that'll conclude this list, is we're going to completely eliminate the risk of something called pretest reactivity. Pretest reactivity is almost exactly what it sounds like. It's when our research participants, our subjects, are reacting to the first test. They're not changing because of the treatment they're receiving. They're changing because of the testing they've gone through. So a pretty classic example here would be IQ tests. IQ tests have questions on them that are supposed to be completely novel, questions you're not familiar with, because it's testing your ability to think and reason and solve the problems. So imagine that I'm doing a repeated measures design. I give you an IQ test, then I give you some treatment that's supposed to change your intelligence, and then I give you the exact same IQ test again for the second measure. Well, if your scores go up, maybe it's because of the treatment, Or maybe it's because you're better at the test. You've already heard these questions. You've already thought through the answers. A big part of IQ tests is time. The faster you get the right answers, the higher your score goes. So maybe I asked you a question and you got it right the first time, but it took you 2 minutes to figure it out. Well, 6 weeks later, I'm giving you the exact same test. Maybe you just remember the question, and now you answer it in 2 seconds instead. Well, your score is going to skyrocket. You're reacting to the test, not the treatment. That's pretest reactivity. But with with an independent measures design, I'm never going to measure you twice. I measure everybody in sample A once, and I measure everybody in sample B once. Since nobody takes the same test twice, there's no chance for pretest reactivity to occur. We can't have you react to the test on the next measurement if there is no next measurement. So it completely gets rid of that particular problem. So that's another advantage of an independent measures design over repeated measures design. The last thing for us to touch on here is the assumptions for a repeated measures t-test. And there are only 2, and they're the same 2 we have had every chapter. Oops. The first one, of course, being independent observations. And the second being that the population, we're back to singulars, only one population we're sampling, is normally distributed because a t-distribution is essentially normal. So there's no extra ones this week. It's the same old 2. So with that, we are done with the lecture for Chapter 11 for our final t-test. As always, don't forget to keep reviewing your mantras. What happens to error if sample size goes up? What happens to error if variability goes up? And then as a result, what happens to the t-statistics and your odds of rejecting? If the mean score differences, in this case represented by, in this chapter, the mean of different scores, if that number gets smaller, what happens to the z-statistic? And if the z-statistic goes down, what happens to your odds of rejecting? So keep grinding those mantras so you've got them at your the tip of your mind, if you will, your fingertips when you take the quizzes and exams. So that finishes that. From here we go to exam 3. Remember what I've said to you for exam 3, after the quiz for this, of course, that you're going to get 3 hypothesis tests, 1 from each chapter. The very first question is what? Which test should you be doing? A single sample T, an independent measures T, or a repeated measures T, and then do that test. So you've got to make sure you're picking the correct test to know that you're doing the correct formulas and the correct math. Other than that, it'll be structured roughly the same. Multiple choice for part 1, and essentially constructed, calculate it yourself for part 2. There's probably more points going to be coming for part 2 than part 1. We've got a lot more hypothesis test work to do than we have new vocabulary, if you will. But as always, I try to keep it fairly balanced. So make sure you're studying all the chapters for the exam and making sure you're keeping each of the chapters clean in your head. Anything you need from me, you know what to do. I normally say come on down and say hi, but send me an email or a voicemail or what have you, and I'll try to get back to you for anything you need. There it is, everybody. Good luck. Hope everyone's still doing well. We will see you sometime down the road.